Discoveries in the fields of cosmology, physics, and biology have led the scientific community to acknowledge that the universe and life on Earth are essentially part of a grand design. Today, many scientists believe that only humans possess the ability to co-create and design this infinitely perfect universe. So, does creation truly exist or not? Professor Monica Grady, head of planetary and space science at Australia's Open University, analyzed this issue based on fundamental principles of physics. I used to believe in God, but now I'm an atheist. While attending a seminar, I heard this question for the first time, originally posed by Einstein, and was overwhelmed by its philosophical depth. If there exists a creator who fashioned the entire universe and all its physical laws, would he himself be bound by the very laws he established? Or could God alter the very laws he established, such as surpassing the speed of light to be present in two different places at once? The answer to this question could help us determine whether God truly exists or not. Or is it where scientific positivism and religious faith meet, yet no answer can be found? I was utterly surprised by that question and immediately felt drawn to it. The timing of the question was hardly surprising. Tragedies like pandemics often make people question the existence of the Creator. If there is a benevolent supreme being, why would he allow such a horrific tragedy to happen? Therefore, the notion that God could be bound by physical laws, which only govern the realms of chemistry and biology, is difficult to accept. Therefore, the limits of medicine are an interesting topic to explore. If God cannot break the laws of physics, perhaps he is not as omnipotent as you would expect from a supreme being. But if you have the ability to do that, why have we never seen any evidence of the laws of physics being broken in the universe? To solve a problem, start by breaking it down into smaller parts. First, can God move faster than light? Let's analyze this issue from a surface-level perspective first. Light travels at an astonishing speed of 299,792 kilometers per second. Hear the engine sound of the USS Enterprise in Star Trek when the dilithium crystals are tuned to maximum power. But is that really the truth? A few years ago, a group of physicists hypothesized the existence of a particle called the tachyon, which could travel faster than the speed of light. Fortunately, the likelihood of them existing as actual particles is considered extremely low. If they exist, they would possess virtual mass and cause the fabric of space-time to warp, breaking the laws of karma and giving God a headache. So far, it seems no object has been recorded to be capable of moving faster than the speed of light. This in itself does not prove or deny anything about God. It only knows that light travels extremely fast. Things get a bit more interesting. When you look closely, consider how far the light has traveled since the very beginning. Suppose a massive explosion occurred exactly as hypothesized in the universe's history, and the speed of light is 300,000 kilometers per second. We can calculate that in the 13.8 billion years of the universe's existence, light has traveled a distance of approximately 10 to the power of 23 kilometers. This existence, or more precisely, the presence of the observable universe. The universe is expanding at a rate of nearly 70 kilometers per second per megaparsec, where 1 megaparsec is equivalent to approximately 30 trillion kilometers. According to current estimates, the distance to the observable edge of the universe is approximately 46 billion light-years. As time passes, the expanding universe makes light travel farther to reach us. The vast universe contains countless observable galaxies, but to date, the most distant object ever discovered is a galaxy named GNZ11. Observed through the Hubble Space Telescope, this distance is approximately 10 to the power of 23 kilometers, equivalent to 13.4 billion light-years, meaning light from that galaxy would take 13.4 billion years to reach Earth. However, when the light began its journey, this galaxy was only about 3 billion light-years away from our own, the Milky Way. We cannot observe or see the entire universe that has formed since the Big Bang, because light from the most distant regions has not yet reached Earth due to the limitation of time. Some people believe it's impossible to say for certain whether the laws of physics break down in other regions of the universe. Perhaps these are merely random, localized laws, and it is this very notion that leads us to an entity greater than the universe itself. Many scientists believe that our universe may only be a part of a much larger space, a multiverse, where multiple distinct universes exist in parallel but do not interact with one another. The theory of cosmic expansion has reinforced the idea of a multiverse. The idea that the universe underwent an extremely rapid expansion phase before it reached the age of 10 to the power of -32 seconds. The expanding universe theory is a significant concept because it helps explain why the universe has the shape and structure we observe around us. If the universe could expand once, then why couldn't it happen multiple times? From the experiments, we have confirmed that quantum fluctuations can suddenly generate particle pairs, which then vanish almost instantly. And if these fluctuations can produce particles, why couldn't they also create complete atoms or even entire universes? Some argue that during periods of chaotic expansion, the pace of development is uneven across all things. Quantum fluctuations during expansion can form explosive bubbles, which then develop into complete universes according to their inherent nature. But the question is how the concept of God can be reconciled with the multiverse theory. One issue that puzzles cosmologists is that our universe appears to be finely tuned for life to exist. The fundamental particles formed from the Big Bang possessed the precise properties to create helium and deuterium, key elements that shaped the first stars in the universe. The physical laws govern the nuclear reactions inside these stars. Then, elements such as carbon, nitrogen, and oxygen were formed, giving rise to life. Why do all the physical laws and constants in the universe have values that allow planets to form and lead to the emergence of life? Some people think it's just a lucky coincidence. Some people argue that the fact that physical laws are compatible with life is nothing surprising. Ultimately, they created us, so what else can we possibly see? However, some adherents of theism argue that this proves the existence of God, the one who created those favorable conditions. But God is not a reasonable answer from a scientific standpoint. Instead, the multiverse theory could unravel this mystery as it allows for the existence of multiple different universes. There are different physical laws. So, it's no wonder that we suddenly find ourselves existing in one of the few universes capable of sustaining life. Of course, one cannot deny the possibility that a supreme being created the multiverse. Everything is just a hypothesis, and this is also one of the most heavily criticized points of multiverse theories. That's because there seems to be no interaction whatsoever between our universe and other universes. The concept of a multiverse cannot be directly verified. Now, let's explore whether God can be present in multiple places at the same time. Most of the science and technology we apply in the field of space exploration is based on theories that defy common intuition. The tiny world of atoms and particles is called quantum mechanics. This theory allows for the existence of a phenomenon called quantum entanglement. The particles are strangely interconnected, as if bound by a mysterious, distant entanglement. If two quantum particles are entangled, acting on one particle will instantly affect the other, even when the two particles are far apart and not interacting with each other. Here are some clearer and more precise ways to express the phenomenon of quantum entanglement that I would like to present. However, this is quite simple to follow. Imagine a particle splitting into two smaller particles, A and B. The properties of the daughter particles must be synthesized from the properties of the initial particle. This is the conservation principle. For example, every particle has a quantum property called spin. Essentially, they move in a circular motion. If the initial particle has no spin, then one of the daughter particles must have a positive spin and the other must have a negative spin. This means that each particle A and B has a 50% probability of having a positive or negative spin. The actions of A and B are not separate but rather intertwined and closely connected with each other, even if they are in different laboratories on different planets. If you measure the spin of A and get a positive result, try imagining someone else simultaneously measuring the spin of B. To comply with the conservation principle, the measured value of B must be a negative number. But right at this moment, everything began to grow hazy. Like seed A, seed B also has a 50 to 50 chance of testing positive. Therefore, its rotation direction becomes negative at the moment when A's rotation direction is measured as positive. The process of quantum information transfer like this certainly occurs faster than the speed of light. It was Stang himself who likened the quantum ballot garden to a spooky action that could occur from a distance. I believe any of us could overlook the discovery of such a rather peculiar effect like this. Therefore, something exists that is even faster than light. Quantum information is a research field focused on processing and transmitting data based on the principles of quantum mechanics, offering superior security and speed compared to traditional information technology. This neither proves nor disproves the existence of God, but it may help us contemplate him from a physical perspective. Like a sudden downpour, photons exchange quantum information among themselves. And so, it can be present in many places at once, even existing simultaneously across multiple parallel universes. I have this image of God holding giant, galaxy-sized plates and spinning them around, while juggling balls as big as planets. The frequency of information bits travels from one universe to another to sustain the operation of all things. Fortunately, the Lord can handle multiple tasks simultaneously to maintain the fabric of space and time. All you need is a little faith. These opinions have almost answered the previously raised questions. I doubt it. If you have faith in God like I do, the idea that God is bound by the laws of physics is utterly absurd. Because God can do all things, even move faster than light. To believe in God, then this question doesn't. Because there is no God, and nothing can exceed the speed of light. Perhaps this is really a question specifically for agronomists, those who are unsure whether God exists. This is the fundamental difference between science and religion. Science relies on evidence, while religion requires faith. Scientists do not aim to prove or deny the existence of God. They understood that no experiment could prove the existence of God. And if you have faith in God, the discoveries of science about the universe won't change a thing. Any universe can be considered compatible with God. Our perspective on God, physics, or anything else stems from our own way of seeing. Perceptions are shaped by personal experiences and individual knowledge. People with spiritual beliefs often live in harmony with the laws of the universe. By adhering to the highest moral values, humanity draws ever closer to the divine.